Okay, so let's move on to the next presentation, and we're going to be looking at combating research misconduct, reporting, resolution, and prevention. Combating research misconduct, reporting, resolution, and prevention, and this shall be taken by Dr. Stephan Vigues. Dr. Vigues serves as a research integrity officer at the University of Maryland, Baltimore, where he is entrusted with the critical responsibility of safeguarding the integrity of research endeavors. With a fervent commitment to upholding the highest standards of ethics and professionalism in scientific research, Dr. Vigues plays a pivotal role in preventing research misconduct, investigating allegations, and fostering a culture of responsible conduct in research within the University of Maryland, Baltimore community. Holding a PhD in neurosciences, his academic journey has been marked by a relentless pursuit of knowledge and a deep-seated passion for science. In his capacity as a research integrity officer, Dr. Vigues is at the forefront of implementing robust mechanisms to deter research misconduct and address any reported allegations with the utmost diligence. With a keen eye for details and a dedication to a procedural rigor, he navigates the complexities of investigating allegations of research misconduct, ensuring that the principles of due process are upheld at every stage following the UMB policy on research misconduct. Moreover, Dr. Vigues is deeply committed to promoting responsible conduct in research throughout the UMB community. By spearheading educational initiatives and training programs, he empowers researchers, faculty, and students alike with the knowledge and tools necessary to navigate ethical dilemmas and uphold the core values of integrity, transparency, and accountability in their scholarly pursuits. Dr. Vigues' unwavering dedication to research integrity extends beyond the confines of his role at UMB. He belongs to the Association of Research Integrity Officers and shares his expertise in forensic analysis of falsified data during monthly meetings. Once a year, Dr. Vigues co-leads a workshop to train other research integrity officers nationally at a yearly conference, sharing best practices to handle and investigate allegations of research misconduct. Dr. Vigues remains steadfast in his mission to uphold the highest standards of research integrity, to cultivate a culture of ethical conduct that serves as a cornerstone of scholarly excellence at the University of Maryland, Baltimore. Ladies and gentlemen, distinguished participants, let's welcome to the floor of the EXCEL-RITE Conference, Dr. Stephan Vigues. Please give him a round of applause.
Well, thank you so much. Can you hear me properly?
Yes, I can hear you properly. I can see your slides. Please carry it away.
Wonderful. Thank you so much. So that was a nice introduction. I'm sorry. I didn't think that this text would be used for my introduction. The text that you just read was for a grant submission, but thank you so much. It's the best introduction ever. Thank you so much for inviting me. It's a real pleasure to be here. Unfortunately, I would prefer to be physically there with you because I would love to see your beautiful country, but unfortunately, Zoom is very convenient, so I'll be able to do a presentation online. So yes, today we're going to talk about combating research misconduct. And so my role, like you just said, is as a RIO to work at the university and prevent, in a way, and I will explain to you how we do that, and explore the way we can investigate cases when they come to us. So now that I've attended your wonderful conference, I know a little bit where you guys are in the process of building research integrity, and you have the advantage of not being like us in the US. In the US right now, we are fairly well established in terms of research integrity, but we made some mistake. And the good thing for you is that you might be able to avoid mistakes like we did, and we can talk about that later. But the thing is, we first need to define research misconduct, and it's where also your research integrity office might be a bit different from us. What we do, we have decided to go with our main funder at university, which is the NIH, and NIH is under the HHS, the Human Health Services, that is under the Congress. So that's a fairly easy process to understand, but they provide a lot of money. External funding is 32 billion. It might change with a new thing happening right now in the government, but it's a lot of money that is being given to universities, and so universities have to align with the federal regulation. So federal regulation define research misconduct according to the terms that have been described previously by Dr. Resnick and Professor Apgong just now. Fabrication is enhancing digital image partially, which is also falsification, and the border between fabrication and falsification is very hard to define. If you exclude data from an article, you falsify data. If you do some statistical analysis that is not exactly what should be applied to your numbers, it is falsification. And you can create from scratch data that will be considered to be fabrication. And we have seen all of these examples at university. Plagiarism, also fairly easy to understand, is copying paragraph to use in a manuscript that you have used before, and you could also republish your own work, and that is called self-plagiarism. It's more about the copyright issue here. But in any case, all of this does not include honest errors or differences in opinion, okay? So this is the federal definitions, and we do have this definition at university, and we had to draft our UMB policy based on this definition. And we do focus specifically on fabrication, falsification, and plagiarism, but it is up to you to also include more, let's say, misconduct. And you could define misconduct over kind of misconduct. And I'm going to explain to you why we are focusing only on fabrication, falsification, plagiarism. So, like I said before, the Congress gives money to the Department of Health and Human Services at the federal level. And we do have, at the federal level, 3 offices. We have the OHRP, Human Research Protection, the Office of Laboratory and Animal Welfare, OLA, and ORI. ORI is actually the entity that oversees what any institution in the US is doing. And it looks like, when I've seen your presentation, NREC would be the equivalent. What you need to keep in mind is that the NIH that gives money to external labs, because they also have their internal money to do research, the external money is not being, I mean, for different conflict of interest issue, ORI is outside of NIH, and NIH is being overseen by ORI too for investigations. So at the university level, we do have 3 offices. We have the HRPO office, and I believe Sarah Archibald on the first day gave a presentation. I attended. We do have the Office of Animal Welfare that deals with all the protocols for research, what we call the IACUC protocols. And we do have a Research Integrity Office, the office that I'm running. And this is why when we do have clinical trials and that, for example, consent forms that are not signed properly or someone is falsifying signature, this is not considered to be data, and this is in the jurisdiction of the HRPO. Same thing for IACUC. If there's some misconduct related to the animals, mistreatment, this will be taken care of by this office. If clinical trials end up falsifying data at one point, then the RIO, Research Integrity Office, will be involved. But we try to separate all the different offices, but there's a lot of interaction between all of them. We also have the Conflict of Interest Office, and same thing, if there's a conflict of interest, this is the office who's going to deal with it. But if with this conflict of interest, the Office of Conflict of Interest determine that there's an issue with data, they would involve the RIO. So, see, you could change the way this is structured. Like I said, you might decide that the Research Integrity Office is at the top of these 3 offices and decide that this should be handled by the same office. This is a choice that you could make. So now, the role of the Research Integrity Office, like we said, is to prevent as much as possible any issue that could happen in terms of falsification, fabrication, and plagiarism. To do so, we do have a responsible conduct in research training. This training has been determined by the ORI. So we are following their rules, and we are following all the topics the ORI has decided to implement. So many years ago, this was, I believe, in 2015, we had a list of topics that we had to focus on. And this little booklet is available online at the ORI website. Anybody can go there, and this is on the bottom, the link to access it. But if you go on ori.hhs.gov, you go in the resources, and you will find all kind of help. But that is a very useful booklet. And this is all the 9 topics that at the time were set up by the ORI. Each topics, human protection, animal welfare, conflict of interest, they're all there. The data management that was nicely presented just before me is also part of his training, obviously. And we do have some updates every year. And with AI coming in and the way the data is being stored, ORI is trying to adapt to the new topics. And so we do have new topics, but we do have to teach to our postdoctoral fellow and faculty that are involved in training grant, NIH training grants. It's not fully mandatory for the faculty, and we're trying to push for mandatory, to get it as a mandatory training for the faculty. We do believe it's important for them to go through the training, all of them. Like it was said before by Professor Kong, it is true that the basis, graduate student, postdoctoral fellow should go through this training, no question asked. Faculty are more difficult to be convinced to go through the training because they believe they have all they need to know what to do. But sometimes it's very good to have a refresher and explain to them how to store the data, because we had cases at university where we realized the faculty didn't know how to store the data, and they're not used to the new concept of the cloud, of SharePoint, all the new different way of saving data. So that's very important for them to know what's happening now. Just a quick slide here to show you the number of retraction, and there's an increase in retraction. These increase in retractions are many factors, and it's very difficult to know exactly what factors are influencing this number of retraction. But we know that there's more and more different journal coming up, new journal coming up, and with a high, not such a high level of stringency in the way they accept data, so they don't review properly the data, and at the end, these new journals that are not so good are increasing the number here, and people taking advantage of that to publish data that is not properly collected or analyzed. So yes, we are seeing a high number of retraction going on in the next few years. And we're afraid of that. So the problem is now, the prevention is one thing, but like I said, very often, the problem is it is human nature to try to cut corners to get as much as possible. And when I say as much as possible, it's because there's a bunch of money that NIH is providing, and there's a bunch of people trying to get this money, and there's competition. And as soon as there's competition, it is unfortunately human nature for a little portion of these applicants to try to cut corners, like I said, and sometimes falsify the data to be able to apply for this money. And like I said, $32 billion, it's a lot of money, but it's not money for everyone. And so we've seen that, and it will, unfortunately, I'm being pessimistic here, but we will always see fabrication, falsification, or plagiarism, but we're trying to minimize the number of cases by doing the best we can preventing it. Now, I'm going to talk, and it's going to be the biggest part of my talk, about the cases coming at university and how we approach a case when we get a case on our desk. So the first important thing for me to explain is what kind of requirements we need to say this is research misconduct. So we, once again, follow the federal regulation. And to conclude, we have a research misconduct happening on departure from accepted practices among the relevant research community. Each field has its own rules, and it is very important to make sure that we are focusing on the field that the case belongs to. Then the second criteria is the misconduct must be committed intentionally, knowingly, or recklessly. It is or, not and. So it is the most difficult part of our investigation. It's to prove there's an intention, or the person knew about it, or the person was reckless. The definition of reckless is hard, but there's going to be a new definition from ORI coming up soon. And being reckless means, in the case of research misconduct, is you know that what the data that you've been given by your postdoctoral fellow in your lab is bad, but you kind of close your eyes and publish anyway because you're so happy that it goes in the direction you would like to see the data going, that you accept it. That's being reckless. And then the allegation must be proven by the preponderance of the evidence. So it means the committee needs to be more than 50% sure that this is a misconduct and that was done intentionally, knowingly, or recklessly. So all of these different factors have to be included in a report when there's an investigation. So why do we do investigations? Just because we have cases coming to our desk very often. We have a hotline on campus, very easy to find on our website. If you go on the umaryland.edu website, you'll find on the bottom there's a link to hotline, and then if you click on it, you can see that you can easily report any issue. It could be reported anonymously if you want to. This is not a problem, and the person complaining about an issue will be given a key, virtual key, to go back on the website and check if he has an email from us. So this way we don't know who the person is if they want to stay anonymous, and the person can communicate with us. So yeah, so I gave you some examples here that are fairly recent and were pretty heavy in the news, but we do have little cases too that are not breakthrough discovery, but are good enough for the people who are falsifying data to be promoted, for example, and they're taking advantage of publishing quite a lot of papers by using falsified data. So this is one of the few reasons why we want to make sure there's no research misconduct on campus and why we investigate them. So let's talk a little bit about the impact of research misconduct. So there's a lot of money being spent by the NIH on data that is not so real, and in that case, being falsified or fabricated. So this is a study that was done and published in PNAS. What they did between 92 and 2012, a 20-year window, they isolated 291 articles. And it's an old study, and it's very hard to have a new study, but this one shows that 291 articles linked to data that was retracted represent more than $2 billion of funds. So what they did, they tried to do a ramification on all the different studies, trying to replicate the study that was fake. And it's all money spent by a lot of people who didn't know that what they were trying to replicate or what they were trying to pursue was fake data. That's a lot of money, and this is the tip of the iceberg, and it probably like a few percent of what is really happening. The impact of research misconduct on public health. And I have the example of Dr. Wakefield, who published in the Lancet journal in '98. And what he did, and it's becoming back in the news, what he did was to link the MMR vaccine to autism. And the study that he did was completely fabricated and falsified. And, and Dr. Wakefield, because he published this paper, just make people panicking, And a lot of people are still thinking that there's a link between MMR vaccine and autism. And it probably contributed to numbers of measles case going on. I'm not saying it's only him. There's also some religious belief, and there's some different groups in the US that don't want to be vaccinated for different reasons. But Dr. Wakefield just provided them with some excuse to not being vaccinated. And so recently we had an increase in Texas with group of people just being sick and getting measles, and some of them died too. So it's becoming a real problem right now because people didn't want to be vaccinated, and all the people who died were obviously not vaccinated. The impact of research misconduct goes also on the institution financial health, and because what happened now is that the ORI comes back to us, and more specifically the NIH, once they know we have done investigation and prove that someone falsified data, they could come back to us and ask for the money to be refunded. And so we had cases years ago. I've been in the office, it's been 10 years now. We had a case where the person had many R1 NIH awards that were mostly falsified, and it represented $8 million. And when NIH came back to explain to the university that they were the one who were supposed to refund the money, and more specifically the department where the person was working in, it was a real problem. Yes, because faculty, when they sign to get the money, it involves the fact that their department is getting the money, and more specifically the university. And sorry, I went too far. And so it's becoming a problem for the institution. Also, it goes in the news, like it goes in the news, and people who are potentially would like to give money away for like donors feel like university is not a good place to give money away because they do not so good science, very in the news for fabrication of data, and because I have money to give away, I probably would not give this money to the university with fabricated data. Also, if you don't do the proper investigation, it was the case at Duke. Duke University had a long investigation, but for many years they didn't want to look into the complaint from a specific person. And what happened is, using not a flaw, but using some way to sue university, the person was able to get more than $100 million from Duke University because they were not willing to investigate the case. So now I can tell you that Duke University has decided to set up a big office, a research integrity office, and they know that it was a bad idea not to tackle the case once the case was brought to their attention. So it's very important for an institution to investigate a case, at least in the US. Otherwise, financial issue could happen very quickly. So I was talking about Duke University, but University of Maryland too got cases coming in, and we have investigated them. Like I said, it's been taken into the news fairly easily by journalists as long as ORI got. I mean, it's fairly easy for a university to be known with retraction if, let's say, after an investigation, most of the time we recommend retraction and correction, and there are some journalists looking for it. Some of them belongs to the retractionwatch.com website, and I will show you the reference at the end of my presentation. And they are pretty good at contacting us, and then they write articles, and then it goes in the more general public news, and it's becoming more known to the public. So now I'm going to talk a little bit more about the structure of the office and how you can just go and bring a case. So there are different strategies you could set up to get a case coming to your office. We have the hotline. Hotline is a third-party company that works for us, but we don't have any input in who, like I said, who contacts them And so if they want to stay anonymous, we have no way to know. We can be contacted by email if the person wants to be known, or even if they want to stay anonymous by email, I will never communicate the name of the person who brought a complaint to me. It could be through a phone call. A phone call, the person could stay anonymous, or the person could come to our office, and in any case, whatever choice they decide to come with, we will take the complaint and we'll start the process of doing an investigation. So let's talk about the process. So when we receive an allegation, like I showed you, it could go from different way. It could be an anonymous complaint. It could come from the ORI also. ORI, I don't know if NREC could come to you with the allegation, but it's the same way. Once we got it, we start an assessment. Assessment is Kaylin, who's going to present later, and myself. We look at the allegation and we check if it meets the definition of research misconduct. And if there's enough evidence to support it, we're going to go to the next round. Saying that, sometimes I got people just complaining about something, but they don't give us any evidence that this is happening. So if we don't have any, let's say, a figure showing that there's misconduct going on, or just someone telling us this person is publishing quite a lot, I'm suspicious, that's not enough for us to start an inquiry. But if we believe there's enough to start an inquiry, then we're going to start a process of sequestration and making sure that we have the evidence we need. At this stage, the person that is being accused doesn't know anything. We make sure we have a letter from our responsible institutional official, and we get this ready for the respondent. Respondent is the person we're going to investigate. So what we do, we sequester everything. Sequestration could start from the cloud, take everything from the cloud, which is the easiest way for us because we don't have to say anything. We don't have to alert anyone. We work with the IT department and they sequester all the files they can from shared drive, cloud-based server, but also email. The institutional email can be sequestered. Once we've done that, and keep in mind, we're doing that to make sure that the person doesn't destroy any document or delete any document, or we're protecting this person from the process, because this person could be clueless about what is happening, but knowing that we're coming, the person could be just delete things that she doesn't want us to see, and it wouldn't be a good move for the person to try to delete anything. So we're protecting anyone by right away sequestering everything. Then we go in the lab, and then we take everything from the lab we need for the investigation. Lab notebook, computers, we make copy of computers. This take copy of computers might take 1 or 2 days, and then we return everything to the lab so the lab can continue the work, and we can start an inquiry. The inquiry takes 60 days, and I'll show you the timeline on the next slide. Formal inquiry is 3 faculty from the university, and they will look into the allegation the same way we did with Kaylin. But with Kaylin, we're not a committee. We feel like, because of our background, we know what's going on. We are, both of us, neurobiologists. We have different background, but we understand science. Though we want faculty to make sure they agree with our decision to move to an investigation. So the formal inquiry will make this a more official step into an investigation. So an inquiry report is being written, sent to our institutional official. Institutional official is going to read the report, and there's a recommendation for an investigation. Then we move to an investigation. We inform ORI. In your case, you would inform NREC to let them know that you guys are doing an investigation on a specific person. And then we start the investigation. Investigation is 120 days. It gives time for the faculty in the committee to investigate the case. And we help them as a Research Integrity Office with the tools we have. And Kaylin, after me, will talk about the different tools we're using in the office to tackle this task. So they will answer the question if the preponderance of evidence could be applied to this case, and if the misconduct was done intentionally, knowingly, or recklessly. And then at the end of this, there's an investigation report that goes to the institutional official, And we do have some due process. So the respondent has the right to comment on the investigation report. He has the right, or she has the right, to appeal to this investigation report, and the appeal will go to the president. President of UMB will look into it, and if there's an appeal, we will go through an appeal process. So that could take some time. But this is how we have a process that gives due process to the other party, and as a research integrity office, we're trying to stay neutral in the process, but we provide everything the committee needs from the investigation. We do forensic analysis of the data if we have the expertise, and we do also provide help with drafting the report such a way it is at the right format for the Office of Research Integrity when we are at the end of our process, because we would send everything at the end of the process to the ORI so they can see that we have done a good job at investigating their own investigation. And most of the time, they confirm what we have found, and they take their own decision on the person that was investigated. So, like I said, there's a timeline. Timeline could be long. It could be a long process because sometimes we have more than one allegation against one person. The case I was referring to at the beginning, the $8 million that we were supposed to refund to NIH, we had around 60 allegations. So it means 60 figures or issues identified in the work of the person. And we had to investigate 120 different papers. Could be a big investigation. If we have only one allegation, that could go fairly fast, and we usually go into the time frame you're seeing here. We had cases that could last for 2 years, even more. So just keep that in mind. A proper investigation takes time. Okay, so now what could be the outcome? So we have two kinds of outcome. The first goal for university is to make sure that the data that was published is being corrected. That's the most important thing. Then committees are free to provide recommendation against the person that was investigated. So beside paper correction and retraction, they could recommend a special training for the respondent, or a research oversight for a few years, or just making sure that it doesn't have any trainee for a specific amount of time. It could go to a termination of a position, but all of these are recommendations from the committee. It's up to the institutional official and the dean of the school at the end to decide if they go with a recommendation. Most of the time, they agree with a recommendation, and they pursue any kind of recommendation that are being proposed by the committee. Once it goes to ORI, ORI have their own way of dealing with the case, and they could prohibit the respondent from being part of NIH panel. They could make sure that he doesn't, or she doesn't, get any funds or cannot apply for many years at the NIH or federal fund. So there's different way of kind of sanction that we could go for. Now, let's go back to the functionality of a RIO and how the office is working. So like I said, Kelly will talk more about all these tools, but we're using plagiarism detection tools, we're using image analysis tools, and we have forensic software. So the forensic software are more about, we're getting copies from computers, but we're making forensic copy. And so we need to have forensic tools to open all of these computers. They could be encrypted, they could have password. These forensic tools are able to bypass this security. It's the same kind of tools that are being used by the police. Also, forensic software, you have Photoshop, and Photoshop is one way for us to identify issues. So I'm going to show you a few examples to give you an idea of what is our day-to-day work at the university. Beside the administrative side, we also do forensic analysis, and it's more the work of Kelly now, who's specialized in identifying issue in all of these cases and complaints. here you could see a Western blot. You're pretty familiar with Western blot, which is about detecting protein on a gel that has been transferred to a membrane, to a film. Now it's not film anymore, but it used to be. And so we can identify using antibody labeled some bands that are specific to a protein. Sometimes people don't have a signal or forgot to do a specific condition, and because they're running out of time, they decide to duplicate these signals. And here it's the case, lane 9 and 10, there's a duplication, and this is an example. And so we use Photoshop to look at the fingerprint of each image. It's using basically the intensity of a pixel in black and white. In that case, it's a grayscale. It goes from 0 to 256 in terms of pixel intensity. And so what we do with Photoshop, we use a specific gradient map tool, fairly easy to use, that transform each pixel, each intensity of pixel into a color. And it helps us to identify similarity between images. And that's the case here. You can see the shape, you can see also the artifact that we're seeing are very similar. Sometimes intensity is slightly shifted, but probability that these two bands are different is very low. And the preponderance of evidence shows us that this is duplication. That's next is an example where there's no identity, there's no similarity between 7 and 8 are strictly different, and you can see that they are. Okay. So according to ORI, up to now, 70% of research misconduct involved Western blots. I'm pretty sure it's going down a little bit now because Western blots are still something that is being used by researchers, but I have seen more microscopic field being duplicated or falsified, and I'm going to show you example here. I'll start with Western blot because that's the main, still the main issues we're dealing with. When we sequester things from the respondent, what we do is to look for it in the files, and the easiest way to find it is usually in the PowerPoint presentation. And here it's a PowerPoint presentation that was isolated from the disk we sequestered. And once we looked into it, you can see here what we just did was to ungroup the image. And clearly the person didn't try to do like fancy photoshopping. They just took 3 different blots and just put them together without saying anything and just reassembled it. The problem is, in that case, the idea of the paper was about intensity and expression of a protein. And so if you don't do it in the same blot at the same time, or try to find a way to normalize the signal, there's no way you can say this band is stronger than the other one. And in that case, they used 3 different blots from 3 different experiments that were not normalized at all, and they fake it and fabricated it and said this is one blot. And that's not the proper way to do because this is fabrication. Okay, so let me show you the next slide. Same person, it's actually the case that I was talking to you with 60 allegations. That was enough for us to have good example to show you. Once you ungroup everything in PowerPoint, you could identify other issues, and clearly splicing in these blots, you can see that there's a black background behind, showing that at least we have 3 different blots here being put together. We could find splicing here that could not be ungrouped in that case, but clearly we have enough evidence here to say you fabricated the data. The proper way to present a Western blot, and that's what we do during the RCR training, is to explain if you splice it, show that there's a clear difference between your blots, and they are 2 different blots, and put a dividing line to say this is 2 experiments. But doesn't change the outcome of your paper, and it makes it more ethical in a way that you're not hiding the fact that you stick together 2 different blots. Yes, another thing that we train to explain to our trainees is do not change parameters to make data disappear. Once again, this is the same case. This is a grant that this person applied it was about knocking out a specific protein, BRCA1, using different methodology. And the person applying for the grant showed that the technique was working fairly well. The band disappeared. And it seems to be that this blot is black and white with no real gradient, not like a gray background. It's the intensity and the contrast is too high. So once we found this presentation in PowerPoint, and it was fairly easy to isolate it, we just reset the parameters in the presentation, and we could find that the original Western blot was not as black and white as it seems to be, and the band was certainly decreased in intensity, but not disappearing like the respondent was claiming. And all of the grant was basically made with this idea that it was an efficient technique that made the data disappear, and it was not the case. What we did also with the same figure, we looked at the NQ1 and we reset it just by right-clicking, reset it the NQ1, and behind, before it's been cropped by the respondent, we could find the entire film. And the film that you can see is reversed here. It's a beta-actin. It is not NQR1. So it means the respondent decided to take another protein, relabeled it, and claimed that it was NQ1, and it's not the case. Also, just didn't put anything here and said this is a negative control. It is not true. So he also lied on the negative control that were supposed to be there. So this is just to give you an example. Probably one last one with Western blots. It's when you have a high intensity like this, and you say there's a lot of signal going on. If you reset the bands, and it's actually not as strong as the person was claiming. So just cheating, increasing signal, saying this is a highly expressed protein. So we're dealing with Western blot, but we're also dealing with other techniques. All the fields are touched by research misconduct, unfortunately. And this is an ELISA, and I'm not going to be mean enough to explain to you what is an ELISA. I'm pretty sure you all know what it is. The person working on the ELISA to detect this protein was working at the university and was getting some results that, according to our raw data, and I'm not going to go into details, the raw data was dealing with the little threshold, and that was very, 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 very low threshold. And to us, the standard deviation she was getting was not possible. You can see the standard deviation this person was getting was so good with a sensitivity that was not supposedly good enough, that it was suspicious to the people working with her. So once they went into the machine, they realized that the number she was using, 77777 for this specific number in the ileum here, were actually 1, 1, 0, and 1. So she was basically faking the data in Excel. And we were lucky to be able to go back to the spectrophotometer where she was doing the experiment, and we could isolate the data. I'm going to finish with a few examples. I've seen that there's 10 minutes. I would like to have questions. So people are cherry picking pictures. And the reason why is when they do experiment, most of the time, I said they, but when scientists are doing experiment, they sometimes forget to include their negative control because they're doing a lot of experiment. They know that negative control works well most of the time, so they don't include it. And when it's time to publish, they realize that they have good data, but they don't have their negative control. So what they do, and I'm not saying it's the case here, but what they did here was to use a negative control, but it's not real negative control. And I'm showing you why. What I did on the VP1 protein, I just resetted the setup here and was able to find the original film that was used for the figure. And by looking at where this figure VP1 was taken from in this film, I could identify that it was taken from an area that were not supposed to have any data. So obviously in the final figure, there's no data, and it's a nice negative control. But they never ran any negative control in this experiment. Same thing here for macroscopic pictures with a control. You can see the control here, they look negative. They didn't run any negative control. And when they had to publish, they were like, oh my God, we need to find negative control. So what they did and what I did to prove it, we changed the intensity of this figure, and we could identify that they were exactly the same. So they just duplicated controls, which is not the proper way to do. That's called falsification of data, even fabrication of a control. Same thing with Excel. I told you Excel, it's fairly easy. You have a nice curve here going up, standard curve. Just because the person decided to put a number that is not the number that was in Excel. 106 was supposed to be very low here, and the person changed the number to 1006. Once again, that's fabrication. And also fabrication of the time, 0, 12, 24, you see? It was not 0, 12, 24, it was 0, 1, 2, 4. So the person here falsified data. Just to finish and to give a better positive aspect of what we do, it is not always research misconduct. Here, this is the example of a grad student who put this into her PhD in her thesis. 3 sets of numbers, and you can see an increase in the data that she had. Pretty big increase, fairly significant. But the person who used this Excel table didn't know how to use the stats and the standard deviation in Excel. The person did just click on the plus in the corner, just click on error bars, and assume that the numbers she entered here were the proper way for Excel to understand what was going on. And what Excel did put the same standard deviation everywhere without thinking, because the numbers were not properly organized on the Excel table. So the person was clueless with standard deviation and was happy to see a difference between these two numbers. And most of the thesis here was based on these differences in numbers. The PI reviewed it. The PI didn't detect anything. I guess the PI was happy to see a difference. It was like maybe a bit reckless. And I can tell you the PI was the one in trouble, not the PhD student. What I did was to look at the numbers. I redid the standard deviation and could confirm that the standard deviation was so big that there's no significance. And the student didn't see that there's a big number here, 1380, instead of 400 for all of them. And so the PhD student was not critic enough to identify the issue, but the PI should have identified the issue. The supervisor should have seen it. And that was a problem. Grad student was not in trouble, but let's say that the PI was in trouble. So I'm done with my presentation. I'd like to thank you for listening. I talked to you about a few links that you could be interested in if you're interested in falsification and fabrication of data. There's a PubPeer website that people are very active, and we do receive a lot of complaints from this website because they identify issue with some of our faculty, and they're sometimes a good source for us to identify issue going on at the university. Thank you so much.